The National Electrical Code, or NEC, Section 110.15b2 necessitates the identification of conductors through color or other effective methods. This is a fundamental safety measure to prevent electrical shock and ensure proper circuit operation. Specifically, NEC Section 110.15b3 outlines a precise color code that must be adhered to in electrical installations. This section dictates that green or green with a yellow stripe must be used exclusively for grounding conductors. These wires are connected to the grounding system and provide a low impedance path for fault current, helping to trip circuit breakers or ground fault circuit interrupters in the event of a short circuit. White or gray is designated for neutral conductors. These conductors carry the return current in a circuit and are typically connected to the neutral point at the service entrance. All other colors, excluding green, green with a yellow stripe, white, and gray, are reserved for ungrounded conductors, commonly referred to as hot wires. These conductors carry the electrical current from the source to the load. The NEC color coding system is crucial for maintaining safety and preventing confusion during electrical work. It allows electricians and other qualified personnel to quickly identify the purpose of each wire in a circuit, reducing the risk of accidental contact with live wires or incorrect wiring. In situations where an electrical contractor has used the same color for hot, neutral, and ground wires within the same junction box without adequate identification through taping or tagging, this practice violates NEC Section 110.15b2. This deviation from the code creates a hazardous situation, as it becomes impossible to visually distinguish between the different conductors, potentially leading to dangerous errors during maintenance or repairs. Proper identification through color coding or labeling is essential for ensuring the safety and functionality of electrical systems. Now let's turn our attention to the use of mixed wire sizes in electrical fixtures, specifically focusing on the scenario you described where a 10 American wire gauge, or AUG, hot conductor is paired with a 12 AWG neutral conductor in a light fixture. NEC Section 402.8b addresses this situation, permitting the use of different wire sizes for hot and neutral conductors within a single fixture under certain conditions. The key condition is that the overcurrent protection, such as a circuit breaker or fuse, must be sized appropriately for the smaller wire. In your case, where a 10 AWG hot wire is used with a 12 AWG neutral wire, the overcurrent protection must be sized to protect the 12 AWG wire. The ampacity, or current carrying capacity, of a wire is determined by its gauge. A smaller gauge number indicates a larger wire and a higher ampacity. A 10 AWG copper wire typically has a higher ampacity than a 12 AWG copper wire. Therefore, if the overcurrent protection is sized for the 10 AWG wire, the 12 AWG wire would be inadequately protected and could potentially overheat and cause a fire hazard under overload conditions. According to the NEC, the overcurrent protection device is intended to protect conductors against overcurrents from any cause. This protection is typically achieved by using a fuse or circuit breaker with an ampere rating that doesn't exceed the allowable ampacity of the conductors. NEC Section 240.4d covers protection of flexible cords and fixture wires. If a 10 AWG conductor is protected by a 30 amp breaker and a 12 AWG conductor is connected to that circuit, the 12 AWG conductor must also be protected by no more than what it is rated for. For example, if the 12 AWG wire is rated for 20 amps and you have a 30 amp breaker, the 12 AWG wire is not protected. In your specific scenario, the 10 AWG hot conductor is considered overprotected because the overcurrent protection is likely sized for the ampacity of the 12 AWG neutral conductor, which is smaller. The National Electrical Code provides tables that specify the allowable ampacities of different wire gauges based on factors such as the type of insulation, the ambient temperature, and the number of current-carrying conductors in a raceway or cable. These tables, such as those found in NEC Section 310.15, should be consulted to determine the appropriate ampacity for each wire size. It is important to note that the NEC requires that conductors be protected against overcurrent in accordance with their ampacities. The general rule is that the overcurrent protection device should not be larger than the ampacity of the smallest conductor in the circuit. There are some exceptions to this rule, such as tap rules, which allow for smaller conductors to be used in certain situations, provided that they are properly protected. In summary, the use of mixed wire sizes in a light fixture is permitted by the NEC, but it is crucial to ensure that the overcurrent protection is sized appropriately for the smallest wire in the circuit. In your specific case, where a 10 AWG hot conductor is paired with a 12 AWG neutral conductor, the overcurrent protection must be sized to protect the 12 AWG wire. If the overcurrent protection is sized for the 10 AWG wire, the 12 AWG wire would be inadequately protected and could potentially overheat and cause a fire hazard. It's important to consult the NEC and other relevant codes and standards to ensure that all electrical work is performed safely and in compliance with applicable regulations. Also, it is important to consult with a qualified electrician who can assess the specific circumstances of your installation and provide guidance on the appropriate wiring methods and overcurrent protection. Ignoring this can result in major damage. When working with electrical systems, it is always important to prioritize safety and to follow all applicable codes and standards. If you are unsure about any aspect of electrical work, it is best to consult with a qualified electrician. In addition to the specific requirements for wire color identification and mixed wire sizes, the NEC also contains many other provisions that are designed to ensure the safety and reliability of electrical installations. Some of these provisions address issues such as grounding and bonding, overcurrent protection, wiring methods, and equipment installation. It is important to be familiar with all of these provisions in order to ensure that electrical work is performed safely and in compliance with applicable regulations. The National Electrical Code is a comprehensive set of standards that covers all aspects of electrical installations. It is updated every 3 years to reflect changes in technology and to address new safety concerns. The NEC is adopted by many state and local jurisdictions, and it is often used as the basis for electrical inspections. It is essential for electricians and other qualified personnel to stay up to date on the latest version of the NEC in order to ensure that their work complies with the latest requirements. The NEC is a valuable resource for anyone involved in electrical work. It provides detailed guidance on how to perform electrical installations safely and in compliance with applicable regulations. By following the NEC, you can help to prevent electrical shocks, fires, and other hazards. It's also crucial to ensure that all electrical work is performed by qualified personnel who are familiar with the NEC and other applicable codes and standards. Unqualified electrical work can be dangerous and can lead to serious injuries or property damage. The NEC is not a substitute for proper training and experience. It is important to receive adequate training and to gain experience under the supervision of a qualified electrician before attempting to perform electrical work on your own. The electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and following all safety procedures. Never work on electrical equipment while it is energized. Always to energize the equipment and verify that it is energized before beginning any work. If you are unsure about any aspect of electrical work, it is best to consult with a qualified electrician. Ignoring electrical safety can result in injuries. The NEC is a valuable resource for anyone involved in electrical work. By following the NEC and taking all necessary precautions, you can help to ensure that electrical work is performed safely and in compliance with applicable regulations. It is essential to remember that electrical work can be dangerous, and it is important to prioritize safety at all times.